Okay guys, today we're going to use the substitution method to solve systems of equations. First off, let's start with our key term. When solving systems of equations, if a variable is isolated by a coefficient of 1 is 1, then substitution may be the method to solve the system. Steps on how to use the substitution method. The first step is once we have our equation that a variable's like in this one right here, how y is isolated, we're going to substitute this, the 3x plus 8, in for y into the other equation. Then we're going to use the distributive property to simplify and then solve for x. Once you solve for the one variable, substitute that back into either one of the original two equations to solve for the second variable. Okay, let's begin with number 1. So for number 1, like we said, the second equation is isolated for y. So we're going to substitute that into the first equation. So we'll have negative 3x plus 7. Now instead of writing y, we're going to substitute in 3x plus 8 is equal to 2. Now we're going to distribute our 7. The reason we have to distribute is because we have a binomial inside the parentheses. So distribute the 7 to the 3, distribute the 7 to the 8. So we'll simplify. We have negative 3x plus 7 times 3 is 21x. Then we distributed the 7 to the 8. 7 times 8 is 56, is equal to 2. Now let's combine like terms. The negative 3x plus 21x is going to give us 18x plus 56 is equal to 2. Subtract 56 from both sides, so we have 18x is equal to negative 54. Divide both sides of the equation by 18, and we get that x is equal to negative 3. Now to solve for y, we can then plug negative 3 back into either one of the original two equations. I like to always plug it into the one where our variable is isolated, so then all we need to do is simplify. So we have y is equal to 3 times negative 3 plus 8. Now let's simplify and solve for y. So y is equal to 3 times negative 3 is negative 9 plus 8. So y is equal to negative 1. Now remember, when you're solving a system of equations, you're trying to find the point of intersection on the graph. So once we solve for both variables, we're going to write our solution as a point. So negative 3 comma negative 1 would be the point of intersection where these two linear functions would meet. Okay, let's take a look at number 2. For number 2, what's slightly different is both of these equations have a variable that's isolated. Because it's the same variable, we can actually set these equations equal to each other so that we won't even have a y in the equation. So we have negative 2x is equal to 6x plus 24. We're going to solve for x and then substitute it back into one of the original equations to solve for y. So I'm going to subtract 6x from both sides to get x to one side of the equation. So I have negative 8x is equal to 24. Divide by negative 8 on both sides. So I get x is equal to 24 divided by negative 8 is negative 3. Now to solve for y, I'm going to plug negative 3 back into one of the original two equations. I'm going to plug it into the first one. So I have y is equal to negative 2 times negative 3. I'm going to simplify and solve for y, so I get y is equal to negative 2 times negative 3 is positive 6. So my point of intersection is going to be negative 3 comma 6. Now let's take a look at number 3. For this one, although a variable is not isolated, we can still use substitution to solve this equation. Since I have y with a coefficient of 1 in my second equation, I'm going to isolate y and then substitute my equation into the first equation. So in order to isolate y in the second equation, I'm going to add 2x to both sides. So now my second equation is y is equal to 2x minus 13. I'm going to then substitute 2x minus 13 into my first equation for y. So I have 3x plus 2 times 2x minus 13 is equal to 2. I'm going to distribute. So distribute your 2 to the 2x and the negative 13, just like we did in the first equation. So 3x plus 4x minus 26 is equal to 2. Let's combine like terms here. So 3x plus 4x is 7x minus 26 is equal to 2. Let's add 26 on both sides. So we have 7x is equal to 28. Divide by 7 and we get that x is equal to 4. Now we can plug 4 in for x into either the first equation or the second equation in order to solve for y. I'm actually going to choose to plug it into this equation right here, because the equation I have right here is the same as the second equation. I just have y isolated. So then all we need to do is plug it in and simplify. So I have y is equal to 2 times 4 minus 13. Let's simplify and solve for y. So y is equal to 2 times 4 is 8 minus 13 is going to give us negative 5. And then don't forget to write your final answer as the point of intersection. So x is equal to 4, y is equal to negative 5. So our solution to the system is 4 comma negative 5. Okay guys, thank you for watching. Please do the assignment that's on Google Classroom. Remember, just like the past few days, the answer key is attached. It's on the second page. Please make sure to check your answers and reach out to one of us if you have any questions or you want us to check your work because you did something wrong and you can't figure out what your mistake was.